Assalamualaikum. Dear students of 11 and 12, welcome back to my class. Today I am here to explain some mathematical problem based on electrical circuits. Dear students, if you can clear your concept on electrical circuit, then I can give you the assurance that you will surely fall in love with it. So let's do the class. Look, here I have drawn one electrical circuit. It is a combined circuit, because here series and parallel both connections we can see, but it is very difficult to find out the equivalent resistance between A and B. So for finding out the equivalent resistance between A and B, we can apply a simple trick. That is, we can apply the concept of plane of symmetry. So here we can draw a line, okay, that will divide the electrical circuit into two equal halves. Okay, so if we draw here a line, and then we can give the point name is suppose Q, and look here, 1 2 3 4 5 6 7 resistors. So and each of the resistors has the resistance is R. Okay, so when we draw the line here, then it will divide the circuit into two equal halves. So at that time the resistance will be divided equally into two equal parts. That means in this portion R by 2 and that portion R by 2. So in that case the circuit will look like this. So it is A and it is Q. So if we want to find out the equivalent resistance between A and B, then at first we have to find out the equivalent resistance between A and Q. That means RAB equal to 2 into RAQ. That means the equivalent resistance between A and Q, which we will find out, RAB will be twice of that. That means RAB equal to 2 into RAQ. Now find out, it is R, but it will be R by 2 as I have told you. So now look, these R by 2 and this R will be in which connection? Parallel connection. So the RP will equal to 1 by R by 2 plus 1 by R inverse 1. That is 2 by R plus 1 by R inverse 1. That will be 3 by R inverse 1. That means R by 3. So the equivalent resistance of these two becomes R by 3. Let's draw another circuit. So it is R, and it is R by 3. Now look, these R and this R by 3 are in which connection? They are in series connection. So now R is equal to R plus R by 3, that is equal to 4R by 3. Okay, so when these two become 4R by 3, then again draw the circuit. That means you will break the circuit in many parts, then it will be very easier to you to calculate the equivalent resistance. This is 4R by 3 and this is R. Now again these two are in parallel connection. So RP equal to 1 by 4R by 3 plus 1 by R inverse 1, that is equal to 3 by 4R plus 1 by R inverse 1, and finally it will come what? 4R by 7. Okay. Finally the equivalent resistance in this parallel combination will be 4R/7. So I have told you the equivalent resistance between RAB is twice of the equivalent resistance between A and Q. And the equivalent resistance between A and Q we have already find out, that is 4R/7. So here we will put the value 2 into 4R/7, that means 8R/7. So the equivalent resistance between RAB equal to what? 8R/7. That is the answer. Dear students, this type of circuit is very simple, but in your competitive examination this type of circuit can come, and also in MCQ questions this type of circuit sometimes come into the board examination. So very careful about doing this circuit. Now let's do the next one. Here question number 2. There are two circuits, electrical circuits. This is the board question, and it came in the board examination of 2019 in Dhaka board. So here look, two cells in the first circuit, two cells E1 and E2 are in series connection, and each of the cell has the value 1.5 volt and has an internal resistance R1 R2 equal to 0.5 ohm. And in this circuit each of the each of the cell has 1.5 volt and R1 equal to R2 equal to R3 equal to 0.3 ohm. Here in A number you have to find out IS equal to what? Find IS from figure 1. And in figure in number 2B, whose external resistor will be more heated? Because you know, when current pass through any resistor, then heat is produced due to the flow of current. That is, you learn from Joule heating effect, and the formula for that finding out the heat is H equal to I square RT. So we will use that formula while doing B number math. So let's do A number at first. IS. Here all the cells are in series combination. So when all the cells are in series combination, the formula for that is IS equal to NE divided by R plus NR. Here N is the number of cells. So how many cells is there? 2. 2 into 1.5, 10 plus 2 into 0.5, and the result comes 0.27 ampere. So the answer of A number is 0.27 ampere. Now do the B number math. For doing B number, whose external resistor will be more heated? So here we have to find out the main current, that means IP we have to find out. So the formula for IP when the cells are in parallel combination will be what? Let's look. IP equal to ME divided by MR plus small r, that means internal resistance. Here M is the number of cells. Here M 3 into 1.5, 3 into the value of R is 10. 10 plus 0.3, and it will come, let's calculate, 0.15 ampere. Okay, so we can see the current in series combination is more than that of the current in the parallel combination. So I think you can understand whose resistor will be more heated. Again we will do that. So the heat produced through R1, so if it is R1 we will take it as R2. H1 equal to I square RT, that means IS square R1 T, and the heat produced through R2 equal to IP square R2 T. It is equation 1, it is equation 2. Here we have to make the comparison. that whose resistor will be more heated. So we can make a ratio H1 by H2 equal to R1 R2 having the same value, so it will be cut. No need to put down that 0.27 by 0.15 equal to 3.24. That means H1 equal to 3.24 into H2. So the heat produced through R1 will be more than that of the heat produced through R2. The answer is this. Very simple. This type of simple question comes into the board exam. Dear students, here is the problem 3, and here I have drawn one circuit which has 3 loops, loop 1, loop 2, 3. So at first we will name the nodes A, B, C, D, E, F, G, H. Okay, so A, B, C, D, E, F, G, H. Now we have to find out I1 equal to what? I1, the value of I1, and B number is compare the value of I and I2. Dear students, if you have to apply Kirchhoff's law, that means Kirchhoff's voltage law and Kirchhoff's current law while doing this math. So at first, solution of A number, we have to find out the value of I1. So obviously we have to choose this loop. That means loop C, D, E, F, C. I have already told you from where you will start, there you will reach. So loop C, D, E, F, C. Here if we move clockwise, that means in this direction, you can choose any direction, clockwise or anti-clockwise, no problem. So here you can see the main current is I. I current is divided into 3 parts, that is I1, I2 and I3, and we have to find out the value of I1. Now the direction of I1 is in that direction, but we are measuring the voltage moving clockwise, that means in this direction. So 6 minus 6 I1, because its direction is opposite to the direction of current, that's why here minus. Then while moving you will see the positive sign of the cell at first, so you will put here plus 18. Then in this way when you go, then again you will see the positive sign of the cell, that is plus 6 volt equal to 0. So 6 I1 equal to 18 plus 6, that means 24. That means I1 equal to 4 ampere. Is it clear? So the value of I1 is 4 ampere. Here we have applied KVL, that means Kirchhoff's voltage law. Okay. Now B number solution. For doing B number, we have to make a comparison between the value of I and I2. That means we have to find out I2, I3, and if we don't find the value of I3, we will not find the value of I, because I equal to I1 plus I2 plus I3. That is what? By applying KCL, Kirchhoff's current law. Look at this point. If we take this node, that means at the node F, I is incoming and outgoing is I1, I2 and I3. So I equal to I1 plus I2 plus I3. Now choose B, C, F, G, B loop. Okay, this loop B, C, F, G, B loop. Again we will move clockwise. Look, if we go to this direction, which sign of the cell we are seeing first? Negative sign. So minus 6. Then here it will be plus 6I2 because current is going this direction and we are also moving this direction, equal to 0. So I2 equal to what? I2 equal to 1 ampere. Now we have to find out the value of I3. Let's do in the next page. Look, now we will apply Kirchhoff's voltage law in this loop. That means BGHAB, and we will move again clockwise. So if we move clockwise, look, I2 is moving in this direction and we are measuring the voltage in that direction. So it will be minus 6I2. Then I3 is in this direction and we are also going to that direction. Then plus 5I3 plus 7I3 equal to 0. The value of I2 is what? 1 ampere. We put the value, and 5 plus 7, it is 12I3 equal to 0. So 12I3 equal to 6, then I3 equal to 0.5 ampere. So now you can easily find out the value of I, as I equal to I1 plus I2 plus I3. We, by applying Kirchhoff's current law at the point F, we got it. So I1 equal to 4 ampere, I2 equal to 1 ampere, and I3 equal to 0.5 ampere. So my final result comes 5.5 ampere. Here we have to compare the value of I and I2. So we can make a ratio I by I2 equal to 5.5 by 1. That means 5.5. Here is the result. Dear students, this type of simple circuits always come into the board exam. So you will practice a lot. You have to practice a lot. The more you practice, the more you learn to break a circuit. And I have already told you, you will fall in love with it. Really. So today up to this, goodbye.